Used several techniques and tools over the years. One technique that I began using early on was the forced inventory concept. And just a little bit about this tool, it was something developed back in the early 90s by the American Association of Physics Teachers, knowing that there was concern that students were coming out of physics classes and maybe didn't understand the very basics of forces. And their assessment practices at that time showed that to be true, and so they came up with this inventory of basic knowledge connected with forces in motion that students and really anybody in society should have a handle on. Another tool that I've used more recently actually is again from the American Association of Physics Teachers, and this one is actually based upon advanced high school physics courses. It's part of what's referred to as the Physics Bowl, where a number of high school students take part in this every year, and then they have a series of questions which they answer in their own schools, and the results go back for this competition. But I use it, again, because it has a wide range of physical principles, and it's put together by people in the profession of physics and in the teaching profession of physics as well. Helps me focus in on what are the important concepts my students should know, and that also, again, it's usually taken by very high-performing high school students, but it gives me a baseline that I can look at that I can compare then the achievements of my students to as well. I also use sample questions from the MCATs. In my one course, the Life Science Physics, why usually everybody's related to the medical field, and a number of them have aspirations for medical school or dental school. And so it does two things. Again, it lets me gauge at what level should the student understanding be at in order to have achievement on those tests that would get them into medical school or dental school once again. And then I think it also provides in that aspect of assessment motivation for them, knowing that yes, if this is going to be a career path, I'll be asked these questions again. And so it serves that way as well, giving them goals for what we would obtain in class. And finally, the last aspect of it that I utilize, again, I use the results to see how well my students are doing, but integrated into the teaching of the course is that they themselves, the people who put out the test, have a suggestion of what equations a student should have memorized going into the test. And so when I relate that to all of the students as well, it gives validity once again that these are basic things that one should understand in terms of, again, the level that we hope that they achieve at the conclusion of a physics class here at Wayne College.
In the Education Paraprofessional Associate Degree Program, we have a variety of written reports that we use within the different courses. Those written reports are assessed using rubrics, and a rubric is a 1, 2, or 3. 1 meaning needs improvement, 2 meaning it's an acceptable report, and 3 meaning it's an accomplished report, meaning the students have gone above and beyond the requirements of the written report and the goals in the course. Those students who earn a 1 on any rubric must resubmit their reports and earn at least an acceptable before they can go on and get into their field experience. All the rubrics are very closely linked to the course goals, and then ultimately those course goals are linked to the Education Paraprofessional program. In addition, during the field practicum experience, education paraprofessionals are evaluated by their cooperating teachers, again on a 1, 2, 3 rubric basis, 1 being needs improvement, 2 acceptable, 3 accomplished. And that rubric is very specific in terms of very specific criteria that the cooperating teacher is looking at, and that criteria is also linked to the 6 standards from the Ohio Department of Education standards for the Education Paraprofessional program. I use 2 techniques. One is a prompted free recall to look at retention for concepts, terms related to the course that I'm teaching. The other technique I use is an embedded assessment looking at the student's ability to apply concept or terms to novel scenarios. The first tool is a prompted free recall. And it's relatively simple. The course title is written down the left-hand margin of the paper, and each letter is followed by a line. The task for the student is to provide a concept or term that begins with that letter on the line next to it, and then provide a definition or any additional information that they can give. So they take this at the beginning of the term and at the end, and it allows me to see how much they've actually acquired and can retain over the period of time. The second task is simply
of 15 questions that are applied in nature that appear in each of the 4 exams over the course of the semester.
What science is all about is coming up with a question or a problem and then seeking a solution to that. And if we put it in terms of instructors, the question, the problem is how much are students learning and how they can learn more. I think that's central to what we do. It's what we're about. And so including aspects such as this are just ways in which we further our own interests. We're interested in knowing what the students know, again, and again, other methods to find out. And I think I'm kind of lucky in the area of physics. I've mentioned some tools that I've used, like the forced inventory concept and so forth. Why, again, professional groups such as the American Association of Physics Teachers, and there's many others, had started to look at this area, in case of the physicists, about 20 years ago that this was investigated. And so I think another aspect of assessment that should be better known or more widely disseminated is that through the professional groups and so forth, there's lots of tools out there already developed. There's lots of tools in which data, baselines, comparisons are available. And again, with that type of information, one can take, if you will, this academic, this scientific approach to using it in the classroom to further ourselves as teachers and educators, with obviously the goal of more student learning going on in the classroom.
I think assessment is a very, very valuable tool. It helps us to reflect upon our teaching practices. It reflects upon the learning of our students. It's very important to know what the purpose of assessment is. We can't just do assessment just to do it. It needs to have a purpose, and we need to have very specific goals in which we are looking at to assess. So ultimately, I think it's a very valuable tool for us instructionally.
Good.
My overall view of assessment is that I think it's really great when it's done right. When you're doing something that is meaningful, something that you have a question and concern about. Simply doing a pre and a post test to get the numbers to file the form doesn't really give you much to work with.